Hello and welcome to Mrs. Schaaf's classroom. Today we're going to be talking about thermochemistry a little bit more, and I'm just going to be working through some mass to energy conversions for you. So we're going to go from mass to finding the amount of energy required, and then we're going to go backwards and, given the amount of energy, find the mass that is needed. So let's get started. Okay, so the first problem that we're going to do is more than likely example problem number 2 off of your worksheet. And it says what mass of butane in grams is necessary to produce 1.5 times 10 to the third kilojoules of heat. And then it also has a second question, which is what is the mass of carbon dioxide that is produced. So we've got two questions that we're going to be working on here. And it tells us in the instructions that our heat of our reaction is a negative 2,658 kilojoules. So let's go ahead and look again at what we're looking for, which in this case is the mass of the butane. And we are given the amount of heat that we need to produce. So always start with your given. So in this case, the 1.5 times 10 to the third kilojoules of heat. So that's what I am starting with. Now remember, this heat of reaction number is the value for 1 mole of the butane, 13 halves of oxygen, 4 of carbon dioxide, and 5 of the water. And so we're only looking at finding the mass of the butane. So really all I need there is the butane part of it. So remember, from our equation, we know that 1 mole of the butane, 1 because that is our coefficient, produces a negative 2,658 kilojoules. Okay, do your unit cancellation. So now I have moles of butane. It asks for mass, so now we're just going to do a mole to gram conversion. So 1 mole of butane, and I've got that calculated out for you. It's 58.12 grams. Okay. Now we're just going to multiply our numerators, multiply our denominators, and so my numerator I have to be 87,180, and I still have grams left of butane as my label. The denominator is the negative 2,658. Now one of the things about it is this is, when I'm looking at the negative that is in there, this is necessary to produce. If I'm producing, remember, that is also negative. So we can get some negatives in there because we know our mass is not going to be a negative value. Divide that out, and it looks like I've also got 2 significant digits. So multiply it out, round it to 2 significant digits, and it looks to me like we're going to have 33 grams of butane that will be needed. Final answer. Okay, so now remember, there is a second question on this one, which it wants to know what is the mass of carbon dioxide that is produced in this problem. So here is our carbon dioxide. So if we know we're going to have 33 grams of the butane, and I want to know how many grams of carbon dioxide are produced, we can just do a mass to mass problem. You'll remember how to do those and do the mass ratio. So we've got a 1 to 4 ratio of the two. So go ahead and start with what you have. That's grams again. And I know for butane it was 58, whoops, what happened to my pen? 58.12 grams of butane for 1 mole of butane. Our molar mass. Now then, here's where we do our conversion to go from our butane to our carbon dioxide, because 1 mole of butane, and again it's 1 mole because my coefficient is 1, to 4 moles of carbon dioxide. And then it wants to know though how many grams, so we're going to now need to do a gram. So 1 mole of carbon dioxide is how many grams of carbon dioxide. So figure out what is the molar mass of carbon dioxide. Okay, and it should be 44.01. Again, cancel your moles, and now I am left with grams of carbon dioxide, which is what I need. So let's go ahead and multiply across. Okay, so I went ahead and run my numbers. Be sure you've checked my numbers to see if my values are correct, that I didn't miss anything, because what I have it come out to is actually 99.9311. But I could only have 2 significant digits, which would be these two, which would mean I would come to the 9 and round this up to 100, but 100 only has 1 significant digit. So you would need to go to 1.0 times 10 squared. Okay, example number 3. This time we are looking at the synthesis of hydrogen and oxygen to get water. The heat of the reaction is a negative 483.5 kilojoules, and we want to know the minimum mass of the hydrogen gas required to produce 226 kilojoules. Again, we're producing that amount, so it's going to be negative because I'm getting rid of it. So let's go ahead. Again, we're going to start with our given. Now, if you're getting the hang of this, but you're just watching the video just to make sure, I would pause and maybe try to work this out on your own and then come back in and check, or if you need to periodically play the video and look at the steps. But try to do it on your own. Don't just write down what I do. So we've got our kilojoules. Again, I need hydrogen gas, so that's this one here. So now this time it is 2 moles of hydrogen gas for ever negative 483.5 kilojoules. Okay, because we have a coefficient of a 2. Now I'm to moles. So 1 mole of hydrogen gas is going to be, and again, if you don't know where I'm getting these values, please holler, but there is your molar mass of hydrogen gas, and it's H2, so we've got a double hydrogen. Okay, I'm left with just grams of hydrogen as my label now, and it looks like when I did my calculations, I have 911.232 divided by the negative 483.5. Again, looking at significant digits, I only have 3. So I'm going to get a final answer of 1.88 grams of hydrogen gas required. Okay, and that is example number 3. Okay, example number 4 says, what mass of natural gas CH4, which is methane, must burn to emit 267 kilojoules of heat? So again, I'm wanting the mass of methane. Here's my methane. It's going to emit, again, remember emit, giving off 267 kilojoules of heat. So again, we're going to start with our given. We're working only with the methane. I don't care about any of the other part of the equation. And I know, again, coefficient here is 1, that 1 mole of methane produces a negative, let me get that number off there. Oops. negative 802.3 kilojoules. Unit cancellations, I'm to moles, and again, our molar mass. 1 mole of methane is, let's see, I have that figured out here somewhere, I think. Let's see, carbon is 12 and hydrogen is 1. So that's 4, be 16, something like 16.04 grams. Okay, check my math there, but something of that. I know I have it written down somewhere, I just can't find it. Okay, and cancel and multiply across to get your final answers. Okay, so I paused it and finished this on out. So here's what I get my numerator to be, my denominator. Again, going back to our problem, this has 4 significant digits, but the given up here only has 3. So I can only have 3 in my answer. Again, guys, do not assume 100% that my calculations are correct. You check it yourself and make sure I did not make any errors. Okay, and this is our final example that we're going to do. And you'll notice it looks just a little bit different from the other ones that we have done. And the fact that there is a energy value here. So in other words, for this reaction to have to take place, it needed to absorb some energy. Okay, and since it's absorbing energy, we know this one is going to be an endothermic reaction, okay, because it had to absorb energy. So let's go ahead, and it says how much heat is required. So this here, how much of this is going to be required to produce 29.2 grams of ammonia. Okay, so we're still going to work it just like what we did before. Let's write our given down. Okay. And I'm in grams. Since we're in grams, we're going to have to go to moles. So I know that 1 mole of ammonia, I think I have that number written down. Maybe I don't. Yes, 17.031. I think we used that in a previous problem. Okay, so I'm at moles of ammonia. From my formula here, now that's this piece here, 2 moles of ammonia are produced if I absorb 46 kilojoules. So 2 moles of ammonia for every 46.0 kilojoules. I don't know why that's jumping. Okay. And now I have how much heat is required. Here's my answer in kilojoules. How much heat is required. So we just need to do some calculations there. Okay, and I went ahead and ran through the calculations, so be sure you do check mine. 29.2 grams, that is going to be our mass. So we got 3 significant digits. I wasn't even paying attention. We could have used the 17.04. If you did use the 17.04, you might see just a little bit difference on your answer, but that's okay. Okay, I believe that is all of the examples that I have for you before we begin the next. So you go ahead and work the next couple of problems on your own. Again, if you have any questions, please don't hesitate to ask. And I'll work through some more for you, but hopefully you've got it down and you're ready to go. So we'll see you later. Mrs. Schaaf is signing off.